A very good morning to all. Am I audible?
Yes, sir.
And is my screen visible properly?
Yes, sir.
Great. Okay. So this is a last day of our IoT FDP. So today's agenda, what we will be having is on the first session, we'll be discussing about various facts of 5G network, including NB-IoT, that is narrowband IoT, and how exactly NB-IoT we can implement or 5G NB-IoT we can implement in our projects. Secondly, we will be discussing about some use cases of NB-IoT. Then we will be discussing about the security aspect of network, and then we'll conclude with another case study. And on session 2, we'll be discussing about how we can utilize AWS IoT cloud services, what AWS is providing to us. We'll discuss about how AWS is helping developers to visualize their devices, what kind of different services and models that AWS is supporting. And after that we'll quickly have a demo over the AWS infrastructure, where we will be seeing what are the different options under AWS IoT cloud we are having. But unfortunately, I'm not having any device which we can connect to the AWS cloud. But definitely, what I'll do is I'll demonstrate AWS cloud dashboard and how it looks, and where we can include our devices. After that, we'll see how we can take the data set what our cloud have connected and cloud have collected, and then we can import it into machine learning. There is a service, specialized service in AWS called SageMaker. So we'll explore that SageMaker service to have input on your model. So we'll try to keep the second session of the AWS as we can possibly on the demonstration part. Let's see how it goes, as AWS is having plenty of examples to start with. So we'll try to explore those examples as well. So without further ado, let's start with our first session, that is NB IoT. So, talking about the NB IoT, let's first understand what are the different types of activity or the connectivity segments we can get on the 5G. As NB IoT is referred as a narrowband Internet of Things network, or NB IoT M, that we can consider, that is the machine connectivity MC. We can always prefer to use a word. So that is a machine connectivity. But before that, this NB IoT is what we can say a product, or it is a child product of narrowband networks. And though 5G is a broadband network, it supports for narrowband application properly, and it leverages narrowband applications to have a very good energy conservation machines, and it can save your energy, it can save your bandwidth, and it can deliver a maximum throughput through a 5G network. So in a 5G network, we will be having four multi-purpose connectivity segments. The first one is a massive IoT, another one is a broadband IoT, then we are having critical IoT, and then we are having industrial automation IoT. Now let's see one by one. The first one is a massive IoT. So once we talk about massive IoT, then the first thing what we think about big data. Now, the big data enterprise is what we can collect different types of a data, segments of a data, chunks of a data from a different types of a input cycles. So, input cycles may be from a client, maybe from a browser, maybe from a machine, maybe from a server, maybe from a server farm, or maybe from a grid. So, this data is coming onto a cloud infrastructure where it is going to process in a distributed file system. Now, what is a distributed file system? So, in order to understand massive IoT, we need to get some concept over a big data, because it is much likely relate with that. DFS, that is a distributed file system. So what exactly a distributed file system is? The distributed file system means we are having instance of a different compute environments where we can have the large capacity of processing your data. Now, instead of processing a data on a single server, because that single server will have some latency, so network issues will be there, will have some technical problem related with the hardware, can have some CPU segmentation problems, as there will be only a single or a dual core, say a dual CPU kind of architecture on that server. But again, it is limited to the total number of cores what is physically installed. Then it can run out of memory, so the memory segmentation issues can be there. So there are different types of issues which we can face when we are processing large amount of data on a single server. So having a traditional data centers to process this large amount of data, and it is not only a large amount of data, it is a what we can say mixed category of a data. Means we are not getting a single type of a data. It is a text data. It can be a text, it can be a document, it can be a multimedia, it can be a metadata, it can be having any of the sources. It is varying in the source, it is varying in the type, and that we need to process. So distributed file system main concept is we can have our compute environment deployed over the cloud. So once this kind of requirement is coming to process this kind of a massive data, these data or that data, particular data, will be divided into a various chunks, and that chunk is passed on to the various distributed environment or distributed servers. So each server is responsible for solving the chunk what it is received. So in that is the result where we can get a faster deployment and faster resolution of our query, means the faster processing of our data in a very less time. It saves our cost, it saves our time, and definitely it saves the energy what is required, means the electricity or any kind of energy which is required. Even the network bandwidth, everything is saved in this case. Now, taking an example of a distributed file system, if I'm having 100 GB of a mixed contained data to process, so if I provide that on a single server which is having a what we can say uh, 10 GB or 160 GB or 100 GB of a RAM. So it will take around 3 to 4 hours, or maybe a 10, maybe it takes around 1 hour to process that 10 GB of a data, 100 GB of a data. Instead of that, if I divide that data into a chunks, maybe that chunk can be equal. If I'm having 100 GB of a data, then I can divide it into a 10 parts, and that 10 parts is given to the 10 different CPUs which are on the cloud. So what will happen is all these 10 CPUs will start working on that chunk all together simultaneously. In a less than a 10 minutes, the entire data will get processed. Why? Because it is now distributed, and again that processed information will be collected in a single point, and that will be visualized through visualizers. So that is the what the data visualizers are. So once we'll get a chance to discuss on big data and how the cloud computing works in a distributed file system, that time I'll be explaining it with the example and the practicals how exactly this type of a processing is happening. But it saves a lot of time, and the beauty of this distributed system is it can contain massive data. Similarly, in a massive IoT, we are having trillions of devices connected to a different types of a network, and these all networks are jointly creating a single backbone network for processing that data, resulting again it can have a low cost devices. So we can have a small chunks of a devices which can be deployed on this kind of a environment to collect, to sense, to produce a data, or to have that information done. And then we can have a data volume which is being created from this small sensors. It is a very small data volume in that case. So the infrastructure will look like a massive infrastructure, but the result what we are getting, it is a very cost effective, energy conservative, and it will have a better impact on the functionality or on the usability of that use case. So it is having a large area of a coverage. As if we are hiring a satellite frequency for monitoring a geographical location, then it is a very costlier. Then we can have a WSN node, 4 to 5 nodes deployed on a drone or deployed on a single pole in a different geographical location, and they are connected to a single WSN node, maybe any LoRaWAN or any network node, which can be capable to have a synchronization on the transmission and can visualize the data. So it is much easy and much cost effective method than what we are having earlier. So for example, if Google wants to survey a particular geographical location in order to collect latest data to feed into a maps, then what Google is employing now, instead of doing a satellite imaging, a real-time satellite imaging, doing the drone or the plane imaging, in India, plane imaging or drone imaging is prohibited. So it is not allowed for any mapping company to do mapping through air. Yeah, they can do it through satellite, but not from the air. Why, I don't know. That there is some restrictions set it, and that restriction reason is classified as it is belongs to the defense. So don't know, but still, but in some countries they are allowed to do it. So it is what it is giving you a high accuracy, but it is a very costlier matter, because if we can see that though Google is generating a lot of profit through maps by showing some advertisement and that, but ultimately that service is free to use. So they are not making that kind of a profit as far as the Google's official post is concerned. They are not making that kind of a profit. So instead of doing these costlier methods, what now Google or any mapping company is doing, they are having a IoT enabled WSN nodes and wireless sensing nodes, we can see. And those wireless sensing nodes are either on a drone or either on, but drone in India it is not possible. So they are keeping it on a pole, and that physical pole is installed in some areas, and from that they are doing the imaging from the camera and all. So it saves their energy, it saves their fuel cost, it saves their flight time, it saves their money on that flight, it saves the regulation fee, saves the licensing fee. Everything is saved in that case. Only the thing what they required is the continuous power source, and that also IoT is giving us a opportunity. Like we can have a solar panel installed, and that solar panel can produce the energy, and from that we can actually power our device. Guys, give me a minute, someone is at the door, just a minute. Okay, so that is what the energy saving is all about. So it can save our cost, it can save our operational cost, and even all the things. So massive IoT is like that. We can have multiple data nodes connected to each other and can communicate in a single backbone network, or can communicate in a different network in order to process a particular task. What we have observed in this particular scenario, run we can have a broadband IoT. Now what exactly a broadband IoT is, it is having a frequency bands larger than the usual band what IoT WSN or any communication nodes are using. Now resulting higher bandwidth is equal to higher data rates. Now it can provide, now higher data rate means what, it is not rated with our data packets cost, it is rated with the how many data packets we are receiving and how many data packets we are transmitting. So depending upon that, what type of a data we can send. So the large amount of data we can send through a broadband IoT, it has a large data volume as well, as because the the band what it is allocated, the frequency on which it is operating, it is having enough room to accommodate large amount of a data, resulting into a large data volumes. So the large data volumes is equal to a large data which is getting transmitted, though it is having a very low latency. The beauty of broadband IoT is, though it is giving us lot of things, like it can give us a high data rate, it gives us a large data volumes to operate, it gives us a efficiency, it gives us a mobility, and with that it gives us a very important aspect, that is a low latency. Why? Because again, this broadband IoT segment, or we can say the area where this kind of a deployment is there, it is having a connections which is deployed with the nodes which are nearby nodes. So resulting, these nodes can produce very short echoes, or we can say a very short range. So we can experience low latency, so low dropouts or network disturbance is there, and we can have a seamless data acquisition or data transmission, or data can be, what we can say, communicated effectively without having any losses into it. Then we are having a segment which is related with the critical operations of the IoT, that is the critical IoT. Now, can anyone guess and tell me the critical IoT will be a which sector, or in which sector this critical IoT can be deployed very well? Yes, any guess? So pretty much this critical IoT can be deployed in every sector. What we can see: entertainment, automotive, education, healthcare, construction, utilities, forecast, everything we can see. But the most importantly, the segments where we are having, what we can say, a real-time data, which is a very important one. Means, for example, the healthcare. Now here that data supposed to be a very real time and error free and loss free. So in that case, critical IoT applications can be a best match for providing the service. So the services like healthcare, services like satellite imaging, services like rapid transportation, services like emergency vehicle tracking, services like GPS tracking. So there, this critical situation is there, then there we can use critical IoT. And though it is having a bounded latency. Now what is a bounded latency? It is having, the critical IoT infrastructure is having a set of rules to communicate on a specific spectrum or a specific broadband or on a band. So there is a latency ratio which is fixed. So if I fix the delay for a particular network, then that will be a remain there. So that latency has to be there, or that latency will be there. Because sometimes this latency is very negligible, because that is the critical implementation of this. The nature of the implementation is very critical, but it has to have that kind of a latency in order to reset that sensor. Now, what will happen if I don't reset my sensor to zero after providing a particular data? For example, if I'm having a ECG sensor, now I have placed that ECG sensor on a patient. I've collected the information what I want, and now I'm placing on to another patient. Now, if I'm not having a resistance, or if I'm not having a latency ratio set it, then what will happen is that sensor will not get resetted to a zeroth value, and may be producing a wrong input for a second patient. Now, sometime if you observe in our life, day-to-day life, if we are having nowadays in a day-to-day life, we can see that in our normal SpO2 machines, that the blood oxygen saturation machine, the what we are getting, the pulse scanner and the oximeter what we are getting. So if you are reading your readings through oximeter, and then if you suddenly take it off and put it back on someone's hand again, or even on your finger again, then it will hold that particular value for some seconds, and after that it is getting decreases, and then it will reset to a zero, and it will start again reading out the actual value. So this is the perfect example of having no latency in it. So if you are not having a reset timer, or if you are not having a reset program, then that sensor will not reset to a zero, and it can create some ambiguity in reading the information and displaying the information. So in the critical IoT, that latency is fixed, so it is not variable like in massive broadband and industrial automation. That latency is variable. Why? Because in these sectors, instead of critical, we are not talking about the critical IoT, but other segments, if we can see, that latency is totally depend upon the network reachability and network connection, and what band that network is operating. So that latency feature is based on that. But on the critical IoT, network is not a issue, because that network is a higher end network which where we are connecting it. But the reading on the data what it is producing, it is matter. That's why the latency is setted upfrontly. That latency is set for resetting the values and then collecting a accurate data for accuracy. Then it is having a ultra reliable data delivery. Now why? Because in the nature that data is a real time, that's why the reliability over the data transmission is more. That's why it uses ultra reliable frequencies, UML, based on the TCP, so it can reach that a particular destination soon, and very soon, when it is collecting the data. Then it is having a ultra low latency. Now here, if we can see that, what is a ultra low latency and bounded latency. So bounded latencies is a specific what we can say ratio of resetting the sensor values, and here is the low latency, which is based on the network where it is going to communicate. So the low latency is observed by the good quality of the network connection or the network segment what we are having. Then another segment of the 5G is industrial automation, where we can have a different protocol integration. Then we can have a time sensitive networking. We can have a clock synchronization as a service. Now there are different types of services which industry is requiring, and there the network latency needs to be very minimum, and throughput needs to be very optimum. So that's why we can switch to the 5G network to get hold on all these kinds of communication. So looking at this block diagram, if we can see that, uh, now the capability of the 5G is what we can say, it is most more reliable than the 4G network, as 4G is now what somewhat it is outdated, and 5G is taking place of almost everything. So 5G is not giving you a network connection, but it is taking you all the new area. It is taking into a whole new area era, and the area where we can have connected devices. Now this is a very good what we can say analogy, that on a 4G we are just having a network which is a strong. Now on the 5G we are having what? Connected devices, or we can say that connected lives on it, and we can experience the faster, effective, reliable communication with a narrow band IoT inserted into it, and we can have the data flow unencrypted in a 5G network. Now, if you can see that, there is a small chart here which states about industry digitalization with the cellular IoT. Now, this 5G network is also called it as a cellular IoT. Cellular IoT is a very, what we can say, collective term, because once you are having IoT devices talking on the cellular network, the GP, GSM, CDMA, 5G, 4G, LTE, these kind of cellular network, then that particular device is a part of the cellular IoT. We'll take what exactly cellular IoT is, and how the cellular IoT is with the narrowband IoT, putting together what kind of magic things we can have. All things we'll have in just in a moment. If we can see the digitalization over the cellular IoT, that can be of entertainment sector. Nowadays, if you can see, if you going to watch a movie in a theater, if theaters are open now, previously some year back, that film or that role needs to be couriered or needs to be handed over to the uh, theater guy, and then that player is there, and then that role is getting played. But nowadays, these theaters are streaming live. So there is a stream server, and then distributors, mainly film distributors, maybe a T series or Z media or something, whatever the distributors are there, they're having their distributing servers. Through that, they're transmitting it online to the theaters, and then that theater is running that show. Even theaters will not have what we can say, um, situation where they are saving it. So it is totally an online process where they are streaming it in live. There are so many things, or there are so many strings were there which is cut off, and the reliability of the communication is setted over that. So entertainment is again a best example. Entertainment industry is again a best example of including these kind of a transmission media using IoT networks. Then we can have a automotive sector where we are having robotic assistants to help us in a various tasks where humans will make some kind of a error, like welding, stitching the very small or tiny objects, building this tiny object. So there human can make a mistake. So these robotic arms are specifically programmed using some protocols and connectivity options, like it can have infrared connectivity, Bluetooth connectivity, wireless connectivity, or any kind of a wireless connectivity. I'm cutting it short, so I'm taking a collective word, wireless technology. So these robo helpers, or these robotic arms, or any kind of sweeper robots, are equipped with all these kind of a protocol, so they can do their task with the precision. So if you uh, programmed that particular robotic arm to have a weld onto a two surface with this ratio. I don't know, I'm not from that background, so I'm not having an idea or a clue in which measurement that ratio is calculated. But still, if we take it in a nutshell, we want a 2 centimeters bond, or 1 centimeter a bond or something. So that will be done precisely in every single weld what we are getting. So that is what the accuracy we are getting, and that is what the accuracy of signal processing. So when we say a signal processing, it doesn't mean always that we are taking some analog to digital to analog. Yes, it is talks about that, but it can have beyond that. It is what that signal is carrying. That signal is carrying that instruction. So we can call it as a instruction flowing, or the instruction processing. So the instruction processing is also precise. So with the help of these kind of a network and the network capability, the processing of the signal will get improved, and we can get a ultra precision, or ultra precision in the commands, ultra precision in work, ultra precision in a feedback what we are getting. So the best example of this is, I'm not exaggerating it, but the Mars mission, what just NASA have done. So if we take it with the technical term, don't get it into what we can say, country to country, that these countries are doing so well and we are not doing it. So we are not getting into that kind of a drama. But if we can take it with the technical perspective, so that is what the biggest achievement we are having in a real-time data processing, where we are getting real-time data in form of images, audio, and audio video clips. So those images can be put together with the audio stream what it has received, and we can have now a live recording from the Mars. So any it is not wonder that in some years or in the days astronauts will be there, and astronauts from the Mars, they are doing video call to their family mates or the family here in earth, on earth. So that is not the dream now, because that can be possible because of these kind of a technology. So that is what the massive amount of the energy what we are saving, and massive amount of the connectivity what we are getting. So then we can have railways, we can have manufacturing, mining, utilities. Now when we say utilities, means all the other kinds of utility services, maybe a energy distribution company, maybe a water distribution plant, maybe a supply plant, any maybe a logistics, maybe any kind of a utility. So it can be having all the four segments of the IoT or the 5G IoT in it. Then we can have forestry, agriculture, public safety, media production, transportation, smart cities. Then we can have smart ports. These are the water ports what we are having. Then trade ports and all. Then education, healthcare, construction, oil and gas, with warehousing, airline, maritime, and you just name it. I'm having a few names in my mind, so I've mentioned in the slide. But you can think about the industry where we can possibly get these IoT, because some years back there was a machine level automation done, then there is a digitalization done. So we already uh, seen the revolution in industry, from industry O to industry 0.4. Now we are into a industry 0.4, that is 4.0 or something, version 4 we are having, from 0 to version 4 we are having. So in every single version we are evolving. We are from we are from general application, now we are onto a automation. So there are some mechanical automation, then it resolves with the electronical, then there is a digitalization, and now we are onto a complete AI based automation. And we can now say that this industry 4.0 or this industry version 4 is totally working on the automation. And we can achieve lot more precision in this era than the compared to the other factors, right? So then taking the cellular IoT onto a next field, then there are types of cellular IoTs what we can get. The very first type is general cellular, where we can have 2G, 2.5G, then we can have 3G, we can have 4G, we can have LTE, we can have 5G, right? Then we can have the 5G onto it. So that is what the cellular is. Then we can have a wired connected cellular IoT, where we can have POTS, fiber, Ethernet, ATM. ATM is the protocol what we are using, not the normal ATM machines to withdraw money. The ATM protocol. Then frame relays, MPLS, power lines. We are having satellite, C band, L band, short range wireless, Wi-Fi 0 to 11, Bluetooth, BLE, Zigbee, 900 megahertz proprietary, 6 low WP WAN. So 6 low WP WAN is what we just discussed about it in last session. That is what the sub 6 frequency working on low powered VPNs or the WPNs, wide area networks, WANs. So that is what the 6 low pans are. And we can have a Wi-Fi hollow. Then on the low powered WAN and other WANs, we can have WiMAX, Sigfox, LoRa, NB-IoT, where we are going to discuss about. Then we are having LTM. Then we can have fixed microwave. Then we can have Wi-Fi. So these are the different technologies which are involved in transmission of the better IoT solution. So talking about the benefits of cellular IoT, what benefit we can get from cellular IoT, then The first one is the extensive coverage. So, as a cellular IoT is solutions, which is using existing cellular network, and those networks are already established through NSPs, that is, a network service providers. So, IoT devices are what we can say assuring the extensive coverage which already in place, and then it is what the level of network coverage we can see that in as a essential for IoT application, which requires a faster data access across multiple regions. So these regions can be your cities, can be your continents, can be one area of the world to another corner of the world. So that can be possible, and the other network internet connections technology like Wi-Fi, which actually do not provide the same level of coverage or a security, but the extensive coverage what we can get on the cellular IoT is way beyond, and we can have a very low latency on it. Then definitely that cellular network is already established, so we need not to reinvent the wheel. So that is a cost saving also, as a significant investment is already existed in that network. So the infrastructure requirement for a cellular IoT is already fulfilled, and which is in place by these companies. We need not to invest in the different types of infrastructure that we already have. So we can actually have these IoT devices connected in kilometers of the range, because the cellular network is almost having the reachability in every sector. Now it is debatable which company is having better service in which area. Maybe in some part of the country, Idea is best. In some part of a country, Vodafone is. Some part of a country, Airtel is. Sometime it happens like we are sitting in our office, then only Airtel's range is coming, no other telecom services are coming onto it. Even the BSNL is not providing a range. So it may be happened, maybe in some areas only Vodafone is having a reception, no other telecom companies are having. But that is not the part of the cellular IoT. What cellular IoT is all about, whatever the existing network coverage we are having, that we can utilize. So we need not to invest into finding out a solution, or creating a kind of a tower which can have the cellular IoT segmentation. So that kind of investment we need not to do, because it is already done. The very cost effective method it is, because we just need to give a certain amount of data transmission fee to these carriers, like we are paying for the data or the broadband. Similarly, you can utilize the services. Then another benefit what cellular IoT can give us is, I think, a remote management. So every physical device which needs to be regularly checked and maintained, which includes cellular IoT devices like WSN nodes or anything, which is having an online IoT platform, or the ThingSpeak kind of a application like we saw. Then this remote management troubleshooting to the connected devices is very easy in a cellular network, because the reliability of connection is offered by this. So this is what the benefit which ensures the service, or the altered expectations, rather than having the devices check every time by a physical hand. So there we can develop some kind of a mechanism where it can give us a diagnostics data, and we can troubleshoot it here from remotely. Like again, if I'm taking it with space missions, then it will be appropriate communication. Like we are having some satellites roaming on our Earth, and set it onto our Earth orbit, and unfortunately something goes wrong with that satellite and needs to be fixed. So it is not advisable now to send a shuttle, then that shuttle will go to that satellite and make some changes. So there are some equipments which are equipped on the satellite, which can self-diagnose the error, and if that error is a programmatical, or if that error is causing a glitch or something, then it can rectify itself by measuring, or to having some kind of a reprogrammable aspects of the factors. So that is what the remote management is. This kind of a remote management is a very way far, but taking into consideration that if you are having a LoRaWAN device deployed on hilltop area in Switzerland, and you are here in India, sitting at your place, your office is in India, and you wanted to control that device, then that remote connectivity, instead of having it with the broadband connection, because that device is not having a reachability of a broadband, but fortunately that device is having a better reception on the cellular tower, from the cellular tower, then that cellular IoT can be connected. And the beauty of cellular IoT, again, it is like your devices can be connected with a cellular IoT, and the remote management functionality you can do from your broadband, whatever the normal broadband you're having. Right now I'm having a wired broadband of a U broadband or the U telecom. So on that, I can manage my deployed network or deployed IoT instrument on cellular network. So that kind of a functionality, or that kind of a bridge we can get, that is what the biggest what we can say usability case in this case. So that is the remote management. Then definitely we are having a flexibility in connectivity. Now what will be the flexibility means in here? Not all IoT connected devices are the same. So some requires long range connectivity, some requires high data bandwidth, some requires latency, some requires no latency. So there are several categories of a cellular IoT technologies which we can choose from based on our device, what kind of application that device is giving. Now, for example, if we are connecting to a device which does not use real-time data transfer, so we can opt for a cost-effective cellular IoT connection that transmits low data volume. So instead of taking a band with the bigger bands, we can have it with the narrow band. So for this instance, narrow band IoT can be used for a low powered or low bandwidth application, while 4G and LTM can be used for a higher bandwidth and for the low latency network. So there we can utilize it. Then most important part of this deployment would be a security, because once we are dealing with the data speed or data transmission, security has to be there. Just like any other connected device, cellular IoT devices are also need to be secured from different types of unauthorized use, or maybe different types of attacks, or so main important attack is denial of service attack, that is a DOS attack what we observe. So DOS attack is the what we can say a very dangerous attack, where it can totally disturb your network, and it can cause your uh, IoT device malfunctioning as well, because it is kind of a device where it is putting your device in inoperable mode. So maybe if it is from the firmware update, or it can because most of the uh, these IoT devices are open source IoT devices, so we can get a firmwares out of it, or we can get a working instructions, and we can alter with that, and these attackers can alter with that and can do DOS attack on it. And based on the different types of a DOS, maybe packet depth DOS or any kind of a DOS attack, your device may be into a serious problem. It can cause a hardware failure as well. So if you wanted to what we can say protect our cellular connected devices or cellular IoT connected devices from DOS attack, we need to have a cellular devices which are already secured enough, or which is a part of GSMA standard. So this GSMA standards talks about the network security and the prevention mechanism onto a network halt, or any kind of a event where the network can be compromised. So additionally, we can have encryption, which can be enabling our data transmission with the multi-layered encryption approach for a better security. Then we can have devices which can be monitored to identify abnormal and malicious activity. And cellular IoT devices can be again configured to use on a private network, like the VPN or VPS in case of secured cloud, and we can enhance our security. Depending upon depending upon the needs and the IoT devices what we are having and the applications of it, There are primary two types of cellular IoT connections. So first is LTE-M, and another one is NB-IoT. So depending upon the variables and depending upon the use cases, we can switch to LTM or we can switch to the NB-IoT. Then what is the LTE is? It is a faster version of the standard technology what we are using, and it can be self-driving type of vehicle for IoT devices, and it can have a rapid response. Then in LTE also we are having LTE Cat 0, 1, 2, 3 up to 5 kind of a category, which means the different ratios on the low powered solution, where we can support for voice and SMS or and data or broadband on it. So depending upon the use, we can use it. So the narrowband IoT, which ensures the low power connectivity, of course, it is compatible with the different technology and ideally suitable for battery operated devices. As again, if we are repeating this, in our previous session also we talked about, once we are having any kind of a device which is taking energy from a battery, that battery life and battery endurance is playing a very vital role in terms of collecting information. So sometime it happens like your sensor is not providing you adequate or proper information. Adequate information means what? Whatever the ratio you have set it, that much of uh, information or that much of data that device has to collect, but it is not collecting that much, or different or secondly it is not giving you a proper response on it. So that is because of the low battery, or that is because of the higher consumption side on the side of the battery by unwanted application. So in that case, NB IoT is very suitable. So it can improve our battery life, so battery can produce a good backup or good energy, and it can properly saved, because the more the battery you recharge, the more the chance we can get for degrading its performance. So this you can experience, like if you brought a laptop 4 years back, that time, or the battery life what you were having and now battery life what you are having. Or similarly the case with the mobile phones. If you buy a mobile phone now and after a year, if you see a battery needs to be, or that phone needs to be charged after 2 hours or 3 hours frequently. Even this case in my Apple, I brought it 2 years back. That time, once it is on a full charge, 100% charge, it gives me with all the functionality 6 to 7 hours of talk time, or the operational time. Now if I see, if I charge it 100%, and if I'm using all the services, if I switch on my Wi-Fi, or if I switch on my packet data to connect, then that battery start degrading, means the massively, and it drains from 100% to 14% in 2 hours. So that much of battery is degraded. Why? Because of the lot of use. So NB IoT can make sure that the frequency what the IoT device is operating, it is kept at low as it can, so battery performance may get improved. And as much as the battery performance is improved, that kind of a transmission you can get, or the better transmission you can get. Now, talking about the LTEM, that is what the long term evolution for machines. So, this LTME is a second generation of the LTE Cat 0 technology, which is an advanced form of the IoT connectivity devices. And LTM is offers multiple benefits, like it can support for voice transformation, it can support for data transformation, not sorry, not the transformation, transmission, the voice transmission and data transmission. And then relatively it definitely improves your battery life, so it supports for a long battery life, low powered consumption. So LTM connects, it is more suitable in a mission critical application which requires high data bandwidth, and it needs to depend on the real time data transfer. Some examples rated with that is healthcare devices, self-driving cars. So these can be your equipments which are connecting to a medical field. So these are the LTEM kind of application where we can utilize this technology over NB-IoT, but NB-IoT is already included in it. So talking about the NB-IoT more, this is a short form for narrowband IoT, uh, which is again compatible with 4G networks, having a low power and low data transmission. And the benefit, like it is a low power consumption, so long range and reliable connectivity we can get. And it is the fastest growing connection technologies over the IoT devices. So almost every IoT developer, or the almost every IoT, we can say, company or the solution company is providing NB IoT services, right? So furthermore, if we can see the NB IoT as in a different forms, that it is having a wide area technology network. So it is low powered wide area technology, LPWA, called it as. And it can work virtually anywhere, so you can put it anywhere in the globe. You can have it connects IoT devices more efficiently, and already established mobile network which handles small amount of two-way data securely and reliably. Now, when we say two-way data means what? Some bands are offering data transmission like one way. So once you are receiving, then you need to finish with the receiving and then you can upload. But here both the things means the half duplex, full duplex, duplex mode. This kind of analogy comes here. So two-way data transmission can be possible simultaneously. So on the one way it is downloading some facts, and another way that device is producing, so it can transmit some data onto it. Then it is a very low power consumption bandwidth what we can get on a NB IoT. Then it is excellent to extend ranges when we are having underground, or sometime it happens like your network is not there underground or at the parking or the basement. So there we can use narrowband IoT devices or the narrowband IoT frequencies to power those devices, and we can have a better range, as these are excellent in penetrating concrete and other materials, as these ranges are not getting absorbed into a metal very well. So it can bypass the metals and it can reach to a station, or it can reach to a client. Then the easy deployment is possible because the existing cellular network is already there. So we just need to tweak that existing cellular network, or we need not to do any hardware change as such at the tower level. What we can do is we can make the changes, sorry, we can make the changes on our device or on our end itself to be connected to that device. Of course, the network security and reliability is there, as it is having a cellular network establishment, and it is a very cost effective one. Then what will be the different challenges what we can have to implement NB IoT? We believe that wireless future is a secure, stable, and robust connectivity. But many potential connected things which are located in the remote or a hard to reach areas, which is having a long distance from the next cellular base station, means the your tower, which are in shielded areas, or deep buildings or underground structures. Then there is eventually no coverage, or it is very often to have a poor and very less device transmitter to operate at this thing, and that it requires a very high power instrument to search for the range and to get connected onto it, so that draining the battery can be there. Additionally, cellular networks are not optimized for application which only transmit small amounts of infrequent data, because the NB-IoT is all about that. Then further, the existing cellular networks which don't support for power saving capabilities, which makes these standards unsuitable for inexpensive devices which can require battery lives for several years. So in that case, NB-IoT is not going to be implemented, as the NB-IoT is totally based on the existing cellular network or the cellular network establishment. Then again, NB-IoT will connect our devices onto an Internet of Things, which is making many new applications a reality, which is optimized for application which is need into a communication of a small amounts of a data for a very long period of time. So in that case, NB-IoT can be usable. Now, if we can see the direct impact on the industry and where we can use this NB-IoT, so we can have a smart metering solution. Like nowadays, in almost variety of households, we are getting a pipeline gas connections. So these connections are having a very reliable source of a gas, and we will not have a gas cylinder crunch now. But the payment what we are doing, it is done through a metering. So they're having a smart metering solutions, or we can create some smart metering solution for these companies or these private or public companies, means the government companies, for reading that particular readings properly. Because traditionally what it is happening, like our MSCB, our electricity board, the person is coming, that employee is coming to our meter and taking a meter reading manually. Even they are having application now, they are taking a photograph, and then that application is calculating the meter readings by using image processing. But still that person has to visit our metering area and then need to collect that information. So by enabling a smart metering, we can use gas or water meters with regularly and small data transmission, and we can monitor them. The network coverage, which is the key issue in this, but still we are having a very improvised network nowadays, at least in the urban area and in some part of the rural area, but which are extremely rural areas, at the hilltop or in valleys or something. There is a difficulty of getting a proper cellular network or the connection. Then it is difficult in that case to implement NB-IoT with the smart metering. And of course, in that area, we will be not having gas or water meters installed, because there is no feasibility of putting gas pipeline or water pipeline there. Then we can have implementation of NB-IoT in smart cities, which can help local government to control street lights, determine when the waste dustbins are uh, need to be empty. We can have a smart dustbin solutions. We can identify free parking spaces. So if I'm visiting some another place in Pune, and if I wanted to park my vehicle and I'll about to reach my destination in 5 minutes or in 50 minutes, then I can check for a possible parking space before I reach. So I can reserve that parking space virtually for me. So that kind of application we can achieve through NB-IoT. Then monitoring the environmental conditions, serving the conditions of a roads. So there are different types of applications where we can use NB-IoT. Then there is another segment called smart buildings. So the NB-IoT connected sensors which can send alert about building maintenance, then the issues what that building is facing, or the automated tasks such as light and the heat control. Then we can have backup for the building broadband connections. So the NB-IoT can be serve as a backup. Then we can have security solutions. Then LPWAN networks which are connected with the sensors directly to monitor systems, Or when we are talking about the security solutions, we can have a CCTV camera which is streaming live through cellular network. So if there is a power down or any power cut or anything is happening, then these devices can control it very well. Then then we can have easy configuration in some difficult areas where we need to search for the intruder and disables their uh, any unwanted applications which they are doing. Then at the agricultural and environmental front, the NB-IoT connectivity will offer farmers tracking possibilities where they can track for animal movement, they can track for land, they can track for these sensors can give us a temperature, humidity. Then they can actually track the weather condition, they can track their vehicle. So a lot of things can be possible using NB-IoT. Then, if we talk about the NB-IoT's commercial growth, then the growth of the IoT connectivity is expected to accelerate in some two main factors. Like it is pushing a digitalized industry, and it is growing interest of multinational operations to expand their existing business beyond the mobile broadband. So, if you wanted to have the commercial impact on the IoT or the or to NB-IoT or a cellular networks or a cellular IoT, we can actually uh, impact on these areas where we can have smart metering solution, assets management, fleet management. In India, drones flying is not permitted yet, but still we can have it. Then VR, AR, automotive industry, we can have traffic safety, we can have smart grid, collaborative robotics, advanced automation and control. There we can have the low cost devices which can be implemented, which can give us a small data volumes, gives us a high throughput with the low latency, having a ultra reliability with large data volumes and massive number of the connections which are connected, or the applications which are connected, devices which are connected, which can enabled with the most recent industry protocols. Then it needs to be a time sensitive networking enabled networks. Then precise indoor positions for highly critical applications, and it needs to have a very high availability all the time when it requires the monitoring, operation. All these kind of benefits will be there onto a these kind of IoT implementation. So we can say that there will be only a one network having a multiple use cases and the industry which where we can deploy the IoT solution. That is what the cellular IoT is, and which leads us into security specifications of the cellular IoT. Now, talking about the security, that the billions of devices which being connected to IoT through many different connectivity standards. Maybe these standards are licensed cellular spectrums, or these are just broadbands. Maybe when we say a licensed cellular spectrum means NB-IoT, LTM, 4G, 5G. These are what the spectrums are, or which can be a unlicensed spectrum like LoRa, Sigfox, or WS and LANs. So these are what the unlicensed spectrums are. Now, talking about what is the licensed spectrum and what is the unlicensed spectrum. Licensed spectrum means the spectrum which is controlled by the government of that country, and that company has to purchase or has to get a license, or need to register with the licensing authority for specific spectrum allocation or specific band allocation on the frequency. So in India, TRAI and Ministry of Telecom and Broadcast is the appellate authority where you can apply for a specific band on 4G, now for a 3G and 4G, and in future for a 5G. Now, there will be standards which is having in common that we are not developing the data security in mind. For example, cellular IoT with SIM as its standard for network security, but does not protect data during transmission. and it authenticates device to a network, which is having connections which are encrypted. But the protection will end soon once the data arrives at the first cell tower. So it is not only providing end-to-end encryption, because now the end-to-end encryption is totally a different part, but here the device will have encrypted data which is transmitted, but it is limited to a cell tower only, and then that cell tower will do the data acquisition and then transformation with the defined cellular architecture or defined cellular protocol. So what will be the problem of that? So despite common cellular network which is using a SIM to secure connection, but SIM does not secure IoT data, as SIM is used to authenticate device to the network. So this needs to be a concern, and which will not provide any kind of a data security end to end. The certificates which are required for data and device to set up a secure channel is a cloud service. Then the traditional ways for storing these keys and certificates is not scalable for IoT devices. These problem will have the solutions as well. So what kind of a solution we can get? We can get a solution like we can start security where the data is created, or we can have a unique unclonable identity. That is what the UIC is. So unique unclonable identity. Now what is a clonable identity? Your SIM card number, AMSIN number, IMEI number can be cloned easily with the help of some devices or with the help of some softwares and keys. We can have a clone of it, and we can create a rogue, or we can create a fake client device which is communicating with the stolen identities. It is possible, but if we can develop a technology where the unclonable identity based on some kind of a connectivity module is used, then we can save these kind of a connection problems. Sorry. Then it uses the identity to authenticate and encrypt all the data to protect it from the moment it leaves from the device, and it is not always with the cloud service, which results in better secure data transmission from device to the cell, and cell to the end device, which protects the end-to-end kind of encryption, which we can call. Then as it is unclonable, immutable, invisible, and unique identity to authenticate every device, which is a very low cost solution and which is scalable in the market, which results into a resource requirement for IoT devices, which is taking it on a very low consideration, which is a flexible integration with the software and the hardware part, securing all the provided competitive advantage over the security parameters. So this can be the advantages what we can get when we are using a cellular IoT for transmitting our data onto our application. Now, addition to a secure element, it is a dependency on a SE vendor to handle keys. That is what the software vendors are there handles the keys. Extra effort for onboarding ACs would be there, and we need to do this for a very first time, and it is a one-time process. Once we're done with that, definitely we'll have a better security over the data transmission. Now, taking the conclusion of it, if we can see the bottom lines of the benefit, then we can have unclonable, unmutable, invisible IDs for authentication. Authentication and encryption of the data is possible. Strong security at a low price point we can get. Flexible integration in software, which is allowing our open air and over the air updates for existing devices, which can be possible because these all updates are passed or done through what the cellular networks. So Yes, so this is all about the cellular network from my side. Though it is a very massive kind of a network architecture, uh, a day or two or three will not sufficient to talk about its functionality, its advantages, its detailed infrastructure, architecture, and all. But we are keeping it very introductory level. So yes, this is from my side about cellular IoT. If you are having any questions, we are open for question and answer. Very sorry, my day started in the morning 7. I'm taking various batches. So from 7 I'm online and I'm giving batch, and I'm taking this FDP again. So that's why I'm having a bit of a throat ache. That's why I'm not able to stay right now. That's why I'm winding it up 10 minutes before. But yes, we are open for question and answers. Please ask any questions if you're having. Yes. Is there any questions or anything which from participant side to add in this? Okay, so I guess there is no question or no, any point to add in this. So uh, this is from my side. Thank you very much. I will see you in next session. Thank you.
अरे नो ये नहीं तो फन यार